everyone, we're going to sketch the graph of this polynomial f of x. First thing we're going to do is find the degree. Since this is not in standard form, I'm just going to write my multiplicities here. 1 plus 1 plus 1 is 3, so the degree is 3. If you condense this polynomial, you would have x cubed here. So that's an odd number, and our lead coefficient's positive, and we're going to talk about end behavior in just a minute, but the main thing you need to know is that the degree is odd and our lead coefficient is positive. Now the y-intercept is when x is 0, so let's just plug in 0 for x and multiply that and you get 8. So when x is 0, y is 8. Our zeros are when y is 0, so we set that to 0. So that would be, this one would be negative 1. Negative 1 plus 1 is 0. 2 minus 2 is 0, and 4 minus 4 is 0. So our zeros at negative 1 comma 0, 2 comma 0, and 4 comma 0. These are all multiplicity of 1. That means they can cross the x-axis. Maximum turning points is n minus 1. So that's going to be 3 minus 1, which equals 2. And this part we're going to do after we graph. This is where the graph, where y is negative and where y is positive on these intervals. All right, so let's talk about end behavior. We're going back to this. We have an odd degree, and our lead coefficient is positive. So that portion is right here, in this little box right here. So all that tells you is when I graph here, make it a little straighter. That means we're really looking at the end behavior here. This part right here. That means we're starting as we graph from left to right in quadrant 3, and we're ending in quadrant 1. So therefore, quadrant 3, my x is negative, my y is negative, and in quadrant 1, both x and y are positive. And if you look at this, you have x positive, y positive, negative, negative. So that means from 0, as x gets larger and larger, my y2 goes larger and larger. From 0, that puts us in quadrant 1. As x from 0 gets smaller and smaller from 0, so too does my y get smaller and smaller. And that puts us in quadrant 3. So we're going to start in quadrant 3 and end in quadrant 1. Let's graph this. Our y-intercept was 8. Our zeros were negative 1, 2. Why did I put negative 1 there? All right. Negative 1, 2, and 4. Now we're not, this video we're not going to go over min and max. We just know that there's at most 2 turning points because our degree is 3. Since our multiplicities are all 1, that means we can cross the x-axis. We're starting in quadrant 3 and we're ending in quadrant 1. So I'm going up to negative 1 here. That's this portion. It has an odd multiplicity. That means I can cross and go to 8. So something like that. Then kind of comes back down to 2. Now at 2, we also have an odd multiplicity, so I can cross. If you want, you could put 3 in and see where that goes, but we're just going to estimate and just do that. At 4, we also have an odd multiplicity. That means I can cross. So there's your graph. Now we're going to determine where our y is positive. Well, this is the line y equals 0. So y is greater than 0 up here. Y is less than 0 down here. So if we look at where f of x is positive, that starts right here, this portion of the graph. So right through there. That is from -1 to 2. It's also positive here. This portion is above the y equals 0. And that's from 4, if you want, you can put infinity there, from 4 to infinity. Now, where is my y negative, or f of x negative? So it's from down here to here. That's negative infinity to -1. And this little portion right in there. So that's from 2 to 4. And that's it. Thank you. Have a nice day. Bye-bye.